Hi, I'm Michelle,
And I'm Sarah.
and this is Physics Bungee Jumping Experience.
Have you ever wondered why a bungee jumper doesn't hit the ground? Well, as the jumper falls down, gravity does positive work because the force of gravity points in the same direction that the jumper falls in. The spring force of the bungee cord, however, does negative work on the jumper because the jumper is falling down while the cord is pulling up. Additionally, air resistance also does negative work during the fall since it pushes upwards. As the jumper reverses direction and starts to spring back up, gravity is negative work because the gravitational force pulls down while the jumper is moving up. The spring force does positive work this time because it is in the same direction as the jumper's motion. However, air resistance still does negative work because now it pushes down on the jumper. So, that's why the jumper doesn't hit the ground. Thank you.
There are three forces that act upon the bungee jumper. The first force that the bungee jumper experiences is gravity, which pulls down on everything and makes the jumper fall. The gravitational force is almost exactly constant throughout the jump. During the bungee jumper's fall, he or she will also experience a force due to air resistance. The faster the jumper is falling, the more the air resistance pushes back opposite the direction of the motion through the air. The last and final force the jumper experiences is a spring force due to the bungee cord. The amount that the bungee cord pulls back on the jumper depends on how far the cord has been stretched. For example, the farther the jumper has fallen, the more the cord pulls back on him or her.
Although bungee jumping is considered an inelastic collision, it makes use of elastic materials. These elastic materials are defined as materials that return to their original shape after being deformed. To stretch out and return to its original length, these materials require forces. In the case of bungee jumping, the cord is the elastic material and stretches out according to the jumper. The varying weight of the jumper, combined with gravity, causes the cord to stretch out and then return to its original shape. The displacement of the bungee cord is determined by the weight or mass of the jumper as gravity remains constant. Within this situation of bungee jumping, there are three types of energy: potential energy of the gravity and in the stretched cord, kinetic energy of the jumper, and thermal heat energy of the air and other things. Now, we all know that a bungee jump doesn't last forever, and such air resistance is the main reason the bungee jumper, on his or her way back to the top, never quite reaches the place that he or she started the jump from. In fact, as the jumper bounces up and down, each time his or her maximum height gets less and less. This is similar to a ball that bounces lower and lower until it stops bouncing at all. This is because air resistance is working against the bungee jumper, both on the way down and on the way up. It always does negative work and subtracts from the total energy of the bungee jumper. The jumper comes to rest right at the point where the cord pulls up just as much as gravity pulls down. However, the energy does not just go away. It is transferred mainly by friction to the air molecules.